Good morning, ladies and gentlemen. Today we have Major General Srivastava amongst us, who will be taking us through the nuances of mosaic warfare. It's an emerging subject, very relevant in today's warfare, and I'm sure in coming times it will become the bedrock of how wars are planned, fought, and the objectives that we set for us are achieved. Now I'll request Dhruv to introduce the speaker, and thereafter I'll request the general officer to give his talk.
Major General Ashok Kumar Srivastava, Vishish Seva Medal, retired, was commissioned in March 1976 in the Corps of Signal as technical graduate. The general officer has commanded a signal regiment in sensitive Ankur sector of Jammu and Kashmir along the line of control. In his 36 years of distinguished military career, he has tenanted important and challenging command and staff appointments in different operational environments, which include command of an information warfare brigade in Jammu and Kashmir. His staff exposures include Assistant Military Secretary in Army Headquarters, Director Administration of an Infantry Division in Desert Sector during Op Parakram, and Director Electronics in Ministry of Defense. He has also tenanted the appointments of Faculty Commander in Military College of Telecommunication Engineering, MOU, and Additional Director General Tactical Communication and Army Headquarters, wherein he steered pan-India communication projects like Tactical Communication System and Defense Communication Network. In his appointment, he was also responsible for cybersecurity of Indian Army and spectrum management for the three services. He is a graduate of Defense Services Staff College, Wellington, and attended the Higher Command course at Army War College and Advanced Public Administration course at India Institute of Public Administration, New Delhi. His academic qualifications include MSc Physics Electronic, Fellow IETE, MSc Defense and Strategic Studies, MPhil Defense and Management Studies, MPhil Social Sciences and Electronic Warfare course in Signal Academy, Leningrad, USSR, now known as St. Petersburg, Russia. After retirement from service, General Officer has also worked with the corporate sector, wherein he headed technological venture related to communication, surveillance devices, command and control solution, and GIS.
Thank you so much. It's an honor for me to address this august audience. And this topic of mosaic warfare is a very current topic. And as we all know, the warfare has always been evolving. And it is still evolving. We had gone through various stages of other warfare, like we had started with, which were dependent on technology. We had started with network-centric warfare. Then from there were some other types of like multi-domain warfare. And finally, we are coming to mosaic warfare. Yeah. See, first, just give you the meaning. What does mosaic mean in this term mosaic warfare? So, like on the left, you see a picture, which is a well-made picture. So one integral picture is an artistic work. On what you see on the right, are again a picture made out of small tiles, which are and such picture is called a mosaic. The difference is that anything going wrong in the picture left, it will spoil the whole image of that picture. Whereas in the mosaic, even if a few tiles, something wrong with them, those can always be replaced to get the original back. So this is, and in the mosaic warfare, each element of a force, that is any weapon, they all are one element of a mosaic, and they can be put together as per the requirement to fight a certain battle or deal with certain security situations, and then they can revert back to their original forms. And now, for introduction, the mosaic warfare is an operational concept developed by the US DARPA, that is Defense Advanced Research Project Agency, to address the increasing vulnerability of traditional platform-centric force structure in contested environment. Now, the concept proposes a fundamental shift in how combat power is generated, integrated, and employed, which is moving away from concentration and towards adaptability, resilience, and composability. Uh, and this warfare is best understood not as a technological solution, but as an operational design framework with significant implications for command and control, force development, and decision making in future conflicts. Now, as I was mentioning, there has been evolution of warfare over the time. Now, I'm starting with the NCW, which was started sometime in the 80s, to Mosaic Warfare. Now, the evolution of Mosaic Warfare presents a paradigm shift from the connecting monolithic high-value platforms to forming dynamic, centralized kill web using numerous low-cost autonomous systems. This transition is driven by the need to operate in contested environment, move beyond or disaggregate capabilities, and leverage artificial intelligence for decision making. Now, what was the network-centric warfare? Network-centric warfare focus was for networking existing large multi and high-value platforms to share data and create a common operating picture. And the goal was to increase combat power through speed of command and shared situational awareness. However, there were some limitations, like is relied on limited number of expensive centralized platforms that are highly vulnerable to advanced enemy electronic warfare and other long-range anti-access, anti-denial capabilities. Like you can have a ship or a aircraft carrier. It's a huge platform, but it has got a vulnerability because it's a single large platform as other similar monolithic platforms. Then people started of thinking of multi-domain operations. It was similar to NCW, but other domains were also to be integrated, like integrating capabilities across all domains, like air, land, sea, space, and cyberspace. Its goal was to uh, cross-domain synergy using capabilities from one domain to open vulnerabilities in another. And the transition steps, the multi-domain move towards combining manned and unmanned platforms, but often still relied on centralized, slower decision-making process. Everything was not automated. And then the next thought process was decision-centric warfare, which is still the core of Mosaic warfare. And here the focus was shifting from forecasting the perfect battle plan to operating a decision advantage by operating inside the enemy loop, that is inside the OODA loop, observe, orient, decide, and act loop for faster decisions. And its goal was to prioritize adaptability, opportunity, and instead of needing the best weapon, the goal is achieving having more options like functional tiles than the enemy can manage. And finally, the Mosaic warfare. The Mosaic warfare is disaggregation, aggregating functions from large platforms into smaller, cheaper, specialized, automated, and uh, warming, swarming systems, which are the tiles of the mosaic. And the goal is to constructing kill webs rather than the linear kill web. We're coming to that later. The key characteristics are first is the resilience. If a node is destroyed, the network reorganizes itself instantly because there are a large number of nodes connected to each other. And then complexity for enemy. The sheer number of variety of threats confuse enemy targeting. And then there is a human machine team utilizing artificial intelligence to rapidly assemble these components on the fly, allowing for a mix of human command and machine control execution. So this is the basic of the mosaic warfare. We'll understand it as we go ahead. This is just diagrammatically, I have tried to show the concept of mosaic warfare. Like on the left, what we see are the large platforms like there's a bomber or a aircraft carrier or main battle tanks, and these are connected to the command center. Now, what is showing in red cross is a single point of failure. Whereas what happens in mosaic warfare, we have got smaller systems all connected in a nodal form, and these all are the tiles of the mosaic, and they can be organized in a way they are required for a particular operation or a particular task on the fly, uh, and after that they can be after the operation is over, they can be de-aggregated and go back to the normal organization. Now, generally, we have understood this contemporary operating environment. The present environment is characterized by near peer competition. Now, here, what the countries are saying, even US, that whatever technology they are developing, their adversaries are quickly coming out with the countermeasures. So, whatever they are doing, there is a countermeasure, and and if you go that type of battle, it goes into a slogging march, and the decision is not arrived at. And then there is a persistent surveillance which is required, and which is available also now with the technology coming. Long range precision fires are available. Cyber space and electromagnetic contestations are there. And of course, adversaries are always protecting their areas as anti-access, anti-denial technologies. And the implications are that traditional force concentration increases operational risk. And mosaic warfare tends to overcome that. Now, this is diagrammatically showing any adversary doing that A2 and AD in their theater zone. They protect their area with various weapon systems and technologies. And if this has to be dealt with by traditional forces like carrier strike group, they are at a risk, and there are constraints. So this is what the problem with the present day warfare is there. The same thing is here. Platform-centric warfare lies on a small number of high value, as I covered. Then predictable employment patterns, high value targets, then unfavorable cost exchange ratio. We're coming to that, how they are expensive compared to the new thought process. Then potential adversaries have capabilities aligned against each of our strengths and are constantly developing them. Now, incremental survivability improvements do not address the underlying architectural fragility. Like, for example, if you have got certain fighter aircrafts like Rafale, now our adversaries have got similar capabilities, or they're trying to build up similar capabilities, China and Pakistan. They've got F-16s, they have got some Russian aircrafts. And if we further upgrade, they also try to upgrade the system. So that's a constant, this competition is there. This is a DARPA's viewpoint. What they have said, that whatever capability they have got, that have shown Russians and Chinese are developing similar capabilities. And what they have said, that potential adversaries have advanced capabilities aligned against every one of our strengths. Like if they've got a aircraft carrier, they have got aircraft carrier trying to match with them. And they have significantly outpacing us in development of new capabilities. And our systems are still better today, they are saying, but they will eventually surpass us, because there's the type of competition which is going on. Now, what are the origins and rationale of Mosaic warfare as per DARPA? They introduced Mosaic warfare in 2017 and 2019 in response to the recognition that system architecture rather than platform performance had become the decisive factor in contested warfare. And the term mosaic reflects a deliberate design choice, and individual elements are limited in capabilities. Operational effectiveness emerges from composition, and losses are anticipated and absorbed. So it has got cushion for absorbing the losses. Now, they have defined the mosaic warfare defined by the dynamic composition of distributed heterogeneous capabilities to generate tailored operational effects under conditions of uncertainty and attrition. And combat power resides in the architecture in the individual platform. Now this is again diametrically shows the Mosaic advantage. Now there is a A2 and AD threat. The advanced anti-access area tunnel capabilities create contested environment, and then the traditional vulnerabilities are there, which make these platforms vulnerable. And the Mosaic solution with this distributed resilient network of disaggregated systems, they overcome and they promise to overcome these problems. Now here again, the dark argument towards Mosaic warfare, like on top they have shown the development of one aircraft, that is F-22. They say that they had started in 1981. And for completion of this project, it went right up to 2012. It's taken more than 30 years. Now they say that their adversaries, like Russians, during the same period, they have come out with 5 generations of anti-aircraft systems, starting from some their air defense system coming to and is S-500. So they say that whatever they are doing, they countermeasures are equally being taken. So they are not finding much advantage in doing such developments of a high value systems. And he said that Mosaic warfare enhances lethality and surprise and destruction by doing the using the disparate systems. They are from different zones, different areas, but they, as per they can be brought to action on the desired place or desired point of impact. They have made a graph, like they are showing the diversity and lethality of options is on the y-axis, and x-axis is showing the speed and scalability. What they are showing that monolithic system, the diversity and lethality options are lesser, and therefore the speed and scalability are also there. If you see the top graph, where in the case of Mosaic warfare, when the diversity and lethality options are higher, the speed and scalability are also on the higher side, and that's why giving better results. Same thing is showing cost-wise. They are saying that monolithic systems like aircraft carrier, one aircraft carrier has cost them about $13 billion. And if you see, read, but on the right side, they are showing elements. They're the cost, and the combined cost of them is much lesser than what this monolithic aircraft carrier costs. And when these on the right, these elements are combined together, they can create as much power and as per effect as a aircraft carrier. Now, this is what they say, that distributed system must be a mosaic to be. It should be made in such a way that it brings effect and leads to a win. Now, the Mosaic warfare, it has got 3 pillars on which the Mosaic warfare is dependent. And first is the heterogeneity. That is the diverse platforms. Then the connectivity. That has to be omniverse connectivity, resilient network, and node-based network. All nodes connected to each other. So there is enough redundancy. And then the adaptability. The evolution has to be dynamic, like all the platforms are available. That picture which has to be made out of all the mosaic, which has to be made out of all these tiles, has to be very, very dynamic. Now the first pillar is heterogeneity. The Mosaic forces deliberately incorporate diverse systems across domains. They can be manned or unmanned, they can be executive or attributable, can be joint and collision assets. They will have the operational effects will be, it reduces predictability, because with a large number of the tiles which we have got, then it complicates enemy targeting. Again, being diverse systems, and then degrades adversary decision making. This is the heterogeneity. This is how diagrammically shown. This heterogeneity because various types of the air, drones, ships, frigates, tanks, all type of weapon systems are there. They can be heterogeneous, but they can be put together to create a mass and create an effect. The next pillar 2, is connectivity and resilience, which is again very important. The core design principle is resilience through redundancy. And then mosaic warfare assumes attrition as a baseline condition. Then mission success depends on functional persistence and not platform survivability. The connectivity and resilience, I'll give an example of this. What is the lower satellite network? Which what is the name?
Starlink.
Starlink. Now, Starlink is going as per the redundancy. They have got some 6,000, 7,000 satellites. Now, what they say, they are also converting into a star shield, which is for military. And for vulnerability, they say that there are so many satellites, one or two getting destroyed by the enemy will not have any effect, and we will reconfigure within no time. So that's the type of redundancy they are looking for. And in better space, the connectivity is that each node is connected to many neighboring nodes, and the connectivity routes are available, alternate routes are available. So it makes it more reliable and more robust. And then pillar 3 is adaptability. That is rapid. This is an organizational aspect, rapid decomposition. Rather than fixed task organizations, mosaic warfare enables mission-tailored force packages assembled in real time. So it is easier said than done, doing it through software, all these assemblies. But then this has to be, they are aiming for that. And then there is human-machine teaming. Mosaic warfare places increased emphasis on decision superiority achieved through human and machine collaboration. And then commanders define intent and constraints. AI, RFS agents supports option generation optimization. And then machines execute at machine speed. And this compresses the decision cycle while preserving human authority. The final authority remains with human, with the commander. Now, this is the diagrammatically shown adaptability, human machine teaming. The commander, the human, he is the overall commander, but then he is assisted by artificial intelligence. And this collaborative process for rapid adaptive decision making, and it can recompose the task force or that mosaic and go for an operation or a strike. And after that, it can deaggregate. Now, what they call it is a kill chain, and they have shown, there's a difference between the conventional kill chain and the mosaic kill chain. And the conventional chain is being said that it is fragile. Like one has to requires surveillance to find, then it has to fix and it has to track, and after that it has to engage, identify the target, engage, and then assess. This cycle goes on. When mosaic, there is more resilience. It is not only one chain, it's a complete network of chains. The surveillance being carried out throughout the operational area, then the command center is taking all the decisions, and for engaging it, they have got options to have various platforms which are available to them. It can be any type of weapon which they can engage, or a different type of weapons can be engaged. So there is more resilience in the mosaic kill chain. Now, in the command and control implications, again, the normally our command structure is hierarchical. Like you have got a headquarter, and below that you have got subunits. In the mosaic, the command structure itself has to change. You have got subunits or even say as nodes connected to each other. So the whole way of our working has to change, and that has to be given a very serious thought how it needs to be done. And the commander must have to accept decentralized execution, mission command principles, and operations under degraded communications. Like some degradation may take place, but they have to work under that. Again, the operational benefit, we have talked about resilience. We have talked about costs because this is less cost. Scalability will be more. The mass can be created at the point of decision. And then for the enemy, it is going to be complex to, um, to deal with such situations. The other operational benefits, and they I'll not go into because it will take time. Like there are three things required in the Mosaic warfare. There is planning and composition. Then there is interoperability, and then execution. Now, when these different platforms are there, they may be from different organizations. Like there is a offshore attack by the enemy somewhere. Now there will be resources of the Navy, the Air Force, maybe various types. Those all have to be taken together, aggregated together, and then the knowledge of that, okay, what resources are available to us at what level, that execution, and who is asking for all that support, who authorizes, all these things requires very, very deliberate planning and execution. And the authority given to artificial intelligence also has to be taken with a pinch of salt. What and how artificial intelligence is going to take decisions. And then the pathway to Mosaic warfare, initially we have got connecting the mosaics, the ties together. Like the aircraft, the drone, they have to be connected to the ship, to connected to each other. Then the design has to be formed. Okay, which all weapons are required, in what configuration they have to be employed in the mosaic, and then the framework for the particular mosaic for a particular warfare has to be made. And then the kill chain has to be adaptive kill uh, kill webs. So this is how the mosaic has to be created dynamically. And then the DARPA has already started some programs. We are still in the thinking mode about this. They have already started some programs for this warfare. This is SCCTR is a low cost weapon seeker system. And it's a big program they have started. And these systems are versatile. They can be fitted to most of they're costing just about less than 2 kgs. They can be fitted on a drone also. They can fit it on an aircraft also. And it is a common thing. It's a common thing which can be fitted on a different platform, and they will be communicating with each other. And this is what they are saying, that this will reduce cost drastically for such. So ACCTR is they have already given contracts to some dealers. And similarly, there is another program of Trace. Trace is again fitted on to the different platforms, and this is of taking the data from the previous SCTR, and then analyzing them and giving out on a particular format. So this is another program which they have already started in this thing for Mosaic warfare. Uh, so and then they are also improving the geospatial cloud analytics. Now the geospatial analytics in the present form is not suiting. They are feeling it is not suiting, and they are going for uh, uh, cloud-based. They are calling it GIS cloud analytics. So they have got a GCA approach where the firstly availability of GIS data will be more available. They are looking for complete global connects with the GIS data and collecting GIS data for all over the world. We may be looking for a smaller area, but the cloud-based GIS analytics approach, it has got a multi-source, multi-mode data repository. Then they demonstrate ability for automated analytics to scale globally. And then they create analytics marketplace to and for the ease of Department of Defense giving to the armed forces. And this impact will provide better information for the tactical edge based on new space. Then they will increase better space awareness and reduce the cost and increase availability using the cloud analytics marketplace. So this is another project that they have taken up for implementation of this Mosaic warfare. Since they had started in 1718, they have they have taken certain steps in this direction for Mosaic warfare. And they have also got a project for a software. They are calling it Stitches. It's a new tool chain to integrate all disparate systems. Now, all the systems have got different platform, different software. This Stitches is one software. It's a tool chain which will be able to seamlessly integrate all their weapon systems, maybe small system like drones, it can be aircraft, it can be ships, carriers, all this. So this is again a software project which they have taken up, and it has also advanced quite a bit. And they are thinking of automatic chain of custody. They are thinking without any human intervention also, detection, identification, targeting, and strike. It can be taken on by artificial intelligence, though whether the capability is given to them fully or with human assistance, but this capability they are in the process of developing. So the enabling technologies, one is the artificial intelligence, because so much of decision, so much of data is there. Then autonomous systems, secure, resilient mesh network is important. Open system architecture for interconnecting and working with each other. Edge computing. Then technology enables Mosaic warfare. See, technology only enabling the Mosaic warfare. But more things is organizational, how we decide to carry out this type of warfare. This again diagrammatically I have put together those technologies. And data fusion has to be there, modularity has to be there, then communications, manufacturing, autonomy. And see, presently we are hugely dependent on the foreign OEMs for our software. We are working on Windows, we are working on, say, what vulnerabilities they have got, we are not aware. Unless we have our own system, our own processes, our own hardware, our own software, these things will remain vulnerable. So that's why manufacturing is very important. The present government is giving emphasis, but let's see how much time it take to carry out indigenization of that extent. This I leave multi-domain integration, of course, for effect, I think is. I've just made some examples of Mosaic warfare. This is an example of a sea denial. Like there are three frames I have made. And in the first frame, the blue fleet is shown, but the ships, destroyers, frigates, other surface vessels are separated by vast distances in the ocean, appearing isolated and vulnerable. So what frame 2 shows is a digital mesh overlay appears. Bold data link lines connected every ship to every other ship and aircraft and satellite, forming a resilient glowing web over the ocean. And this isolated units are now visually unified into a single combat system over a last event. And of course, the frame 3 shows the strike. The offensive missiles launched from disperse ships simultaneously. The flight paths curve weave from different azimuths, covering on a single enemy task force with synchronized time on target impact. So this requires tremendous coordination. And the distances are different, the flight times are different, their capabilities, what capabilities to be taken from these sources, which type of missile, which type of weapon. But then everything has to be coordinated in such a way that they create that mass and that effect. And similarly, an example of layered air-based defense system. Now, in the air-based defense system, the defensive forces are distributed over so they here what they have shown, they have created three rings, outer ring of radars and other electronic devices and drones. Then I've got a central ring of air defense weapons. Then you have got another inner ring of basically drones, the short range, this thing. And any attack which is on this airbase is visualized. So a mosaic is formed. What weapons, what from which all areas or platforms have to be taken, and then the coordinated effect has to be created. So there are some challenges. Network, yes, network should not fail. There will be all efforts by the enemy to disrupt the network, electronic warfare and other means. AI trust. Now we are talking about AI, but how much AI can be trusted will come over a period of time. Data standards. Data standards are different, and then integrating them together require a lot of effort. Like US is making that stitches software, and that is tool chain. But it will always be good that the data standards are common and well defined. And then, of course, when we are going for such warfare, tremendous testing has to be done, whether in various exercises, trying ourselves whether how we are going to do that. And what is essential? They have said we will also feel that, like we are from the army. Now there's a guy from Air Force, from Navy. There's always been testing about who will command whom. Now here, all resources can be used by one command at a particular place. How that authorization will take place, I mean, this whole thing has to be, there will be a cultural shift to adopt to the new type of organizations, which again will take time, and this needs to be done. And there are some global implications also, which may not be very relevant for us, but for the US, now global implications may be there. There are deterrents of a different kind. Now, in which area we are operating, now you have got to have, like US is operating somewhere in Europe. Now, it has to be in this thing with the European countries, like this thing. Then there are more competition will come up. Then network capabilities also has to be integrated with other countries when one is working with other countries. And then finally, the kill zone where the action is to be taken. All this requires international collaboration also. So the future of combat is network. This is the final word. The future of combat is network. There is one platform. There has to be infinite connections. They will be connected to all. I've tried to make a diagram in Indian context, not the actuals. The Mosaic Warfare Indian context, and one has to see what can be done in Indian context. Like I have just put some enemy ships of fleet entering into our water zone. How this can be dealt with. this is just so. What need to do if we want to? Firstly, we have to assess at which we are at what level, and whether we are able to transform to mosaic warfare all over, or we have to start with some mosaic warfare with some specific units of formation, specialized forces. Those things have to be decided. But then, if we want to do it, then we have to take some immediate steps. We must rapidly adopt a data-centric, decentralized command structure, replacing traditional heavy platform-centric systems. So this itself is a big task, and there should be networked, low-cost, autonomous and unmanned systems like UAV, underwater vehicles, UGVs, and then key actions include investing in artificial intelligence, software-defined radios for interoperability, and robust space and cyber resilience. We've been thinking of introducing software-defined radios till today. There's hardly any progress. Our network for NCW, which was TCS, Technical Communication System, is still not on ground. So we have to expedite all these things. Our tax CCI system, all the systems are not in place presently. Some of them done well, like ACCCS is doing well, and but then all the systems they had started with battlefield management system, which got foreclosed and never progressed anywhere. So if we are thinking of this, it has to be done holistically, so that all the capabilities are there with us. Then adopt decision-centric warfare, focus on enabling faster decision-making through AI-driven analytics rather than relying solely on traditional large military platforms. Then we have to develop autonomous systems and AI, invest in a smaller, smarter, potent, and cheaper mix of unmanned vehicles and robotic systems to reduce risk to personnel and increase survivability. We have to start with a smaller system and ensure interoperability, utilize software-defined radios, and secure shared communication channels to connect diverse platforms across Army, Navy, and Air Force. Till today, we don't have interconnectivity, seamless interconnectivity between Army, Navy, and Air Force. This is being done now, of course, through defense communication systems. But defense communication system is one layer, which connects to their individual Army network, Navy network. It's not, it's through gateways. It is not seamless. And then strengthen technological self-reliance, accelerate indigenous development in AI, cyber, and hypersonic through initiatives like ITEX or other methods, reducing dependence on imported sensors and components. So we have to move in that direction. And we have to leverage space as key enabler. Space, we are doing well. Utilize space-based assets to facilitate the kill web concept, ensuring real-time data sharing and connectivity. Then build strategic collaborations. We have to collaborate with our foreign friendly countries and do it alone. Leverage partnership with nations like the US, France, Israel, of course, Russia also, we have been doing. And this transformation is critical to counter the integrated command architecture from our adversary like China, allowing for more flexible, they call it a like water management. So we have to take these actions, and we can think of because this is definitely going to come. This system is going to come, and why I again showing the slides. Like for example, as I was saying, okay, now if there is a intrusion by a ship, now uh, um, that space will be on some under some naval commander. Now, if decision for a mosaic warfare is taken, at what level the decision is taken, think of. And which all platform, I mean one has to, that artificial intelligence has to tell, okay, which are the platforms or weapons which are within range, which are required, how much of force is required, all those things, who will authorize all those things, can they be authorized on the fly? So there are a large number of questions that we think, and such um, uh, uh, brainstorming has to be done to arrive at how we are going to, and we have to start with some smaller systems. And once we validate those concepts, we can go for larger. Because if somebody says that we can do away with our aircraft carrier or ships or these things, it is the present day, it will take years and years to reach that. Even for USA, it will not happen tomorrow. So it's a futuristic concept, but it's a viable concept of having cheaper, smaller platforms networked together, tiles made into mosaic and creating mass effect. So this is what I wanted to say in the conclusion. It represents a shift from platform dominance to architecture advantage. Its success depends less on technological breakthroughs than on doctrinal adaptation, organizational reforms, and command philosophy. But in our case, even the technological breakthroughs have to be given equal importance because we are not that advanced as compared to USA. And it is imperative that the viability be assessed in Indian context and plans for implementation be initiated in an orchestrated and time-bound manner. So I think this is what I wanted to say about Mosaic Warfare.